In this lecture, we will introduce state space. Let's talk about state. A state is a full description of a system. The state of state a system can occupy is known as its state space. And for these states, they should be different and mutually exclusive. In these slides, we will take a look at several physical systems and their corresponding state space. First, a coin. It has two states, head or tail. We can represent the state space in direct notation in head or tail. We may also represent the state space of a coin using 0 and 1 like this. And we have the corresponding direct notation. The second example is electrical voltage. The state space of electrical voltage consists of two states, either larger than 0 or smaller than 0. We may represent the state space in direct notation in something like this. Or similarly, we can use 0 to represent the positive state and 1 represent the negative state. Lastly, for dice, in its state space it has 6 states. And we can represent the state space using direct notation, using 1, 2, 3, 4, 5. So what is a quantum state? A quantum state is a superposition of classical basis states. So what is superposition? In quantum mechanics, superposition is a fundamental principle that states any two or more quantum states can be added together or so-called superimposed, and the result will be another valid quantum state. And conversely, that every quantum state can be represented as a sum of two or more distinct states. Let's see an example of a superposition of three basis states. Let the three basis states as 0, 1, and 2. And superposition means that we sum over all these states with some conditions, that alpha 0, alpha 1, and alpha 2 are complex numbers, and alpha 0 squared plus alpha 1 squared plus alpha 2 squared equal to 1. And the new state phi is a superposition of three base states. It is a quantum state. A qubit is a special case. It is a superposition of only two base states. For example, this one. Now let's take a look at some example of quantum state system. For example, electron spin. An electron can spin in two different states, either spinning up or spinning down. The quantum state space of electron spin is a superposition of the spinning up and spinning down, which can be represented in this formula. Another example is the electron energy state. It is a superposition of ground or excited states. Lastly, I want to talk about the unit of information. In classical system, a unit of information is represented by a bit, which represents the binary states. The number of states per information unit is 2. For quantum system, a unit of information is represented by a qubit, which is a superposition of two base states. And the number of states per unit is infinite because it is a superposition of two states. The power of the quantum computer lies in the infinite number of states available to each qubit.